Welcome everybody to 52 Living Ideas Science Wednesday. As part of Comprehensivist Wednesdays, this is done in conjunction with the Greater Philadelphia Thinking Society and 52 Living Ideas. So tonight we'll be discussing the roots of consciousness. So Sanjay will be leading the discussion, and then we'll open it up for Q&A, and we'll go from there.
Right, so hi everyone. So we've talked about consciousness at several different events, and I wanted to drill down and go back to the roots of it, figuratively and literally. And there are a few ideas that I think are very important for everyone to understand. And so tonight we'll have discussions as we always do, because I want to make sure that if there's any questions or people, there are many views on this, but I think some of the research that's been going on specifically for consciousness for at least 20 years now really have elucidated areas that were not so obvious just a little while ago. So there's a lot of new information, but we're not going to cover much of the new information tonight. We're really going back to the roots. So some of the these things may be new to some folks, but I wanted to start at looking at exactly the multiple meanings around consciousness. So let me start the screen share. I usually have slides that help with this. So let me just start that. Okay, so hopefully everyone can see this. Again, I think it may block, I think part of my screen may be blocked. I'm not sure how to change that. I'm going to move this at the bottom so it doesn't affect too much of the information. So first what we'll do is let's talk about the rough definitions. Now, consciousness is something that's extremely difficult to define. But there are two definitions that I've found that really, they're general, they're very generic. And one of the reasons why we need a generic definition is because consciousness, many people think consciousness exists only in people and human beings, but actually it exists in many animals, not only mammals, but even, lower primates, actually sort of lower reptiles and other avian, birds and other species. So consciousness is not only mammalian, it's definitely not primate or human exclusively. And that's the reason why the definition has to cover a lot of different types of behaviors that are included within it. So these two definitions, I think, kind of cover it. The first one basically says consciousness is taking in external stimuli, which is information, for the purpose of survival. And this is very, very broad. And this intentionally is broad because it has the essential elements of what a brain does. And in a sense, what this definition encodes is the many different purposes that we have a brain, that any organism has a brain, has a neural tissue. And this taking in of external stimuli can be done either passively or actively. And for the lower animals, it's done passively. They're not really, what I mean by passive and active in terms of consciousness is that we humans, when we think of consciousness, we only think of it as an active process. We are aware, that we recognize things, that we notice. But a lot of the lower animals don't have that type of consciousness. They're not aware that they're aware. They're not even aware that they have a body many times. Many of the lowest animals aren't even aware that they have a back or that they have a tail, or the extremities of their body. They might see those extremities and they might recognize them to some extent, but the conscious awareness of this arm that moves around is physically me. That awareness varies at the different levels of animals that exist in the world, and also in the various levels of conscious abilities. So this definition, again, and when we're talking about passive and active, this is kind of pushing us into this understanding that consciousness exists in many different organisms, even the most primitive organisms, insects also, though we would not think of it as active consciousness. Those would be more passive consciousness. So that's one definition, and then we can expand on it. We can discuss that a little further. Another definition, Michael Graziano, he's a neuroscience researcher. There's a TEDx talk that he did a couple of years ago, and that's one of the videos that I linked to. And in that, he describes this one quote, that consciousness is our brain's imperfect picture of its own activity. And this definition actually has a lot behind it that may not be apparent if you simply read it. And the word imperfect actually has a lot going for it, and I'll get into that a little bit more. But what he's saying, but first, his specific definition is geared toward the higher order behaviors of consciousness, the active types of consciousness, because when he's talking about the brain having a picture of its own activity, that's active. The brain has to observe itself. It has to look at itself in a way, not using eyes, but it has to use parts of the brain to look at other parts of the brain. And that's an active process. And that can happen passively. But in animals where that happens passively, those animals don't have a realization that they're doing it. One part of the brain may realize another part of the brain is doing something. Like, for example, the part of the brain that's moving, its legs, may realize that another part of its brain has detected a threat in the distance. And so the part that's moving, its body, may stop moving because there's a threat, that's perceivable at a certain distance. So, but that probably is not, in most lower forms of animals, it's not what we would call a cognitive type of realization that they have observed something. Therefore, they recognize it to be a threat. These are all what we would call subconscious in our way of understanding. We have a lot of processes that are subconscious, which means basically that it does not rise to our conscious awareness. We don't have an understanding that our brain has this level of information in it. And that's the level at which a lot of the lower life forms, organisms, operate. They don't have a realization that they have information in their mind. There is information in their mind. When their eyes see something, that literally puts information into their parts of their brain. And that information gets processed, and that processed information goes to other parts of their brain. So their brain is doing a lot of complex things, but they may not have a realization that all of these things are happening in their brain, that they are understanding the world around them in the way that we understand the world around them. They do understand, but they have a much simpler level of understanding. So using these two definitions, let's just do a quick Q&A and see if anybody wants to add to or maybe wants clarification on why some of these things are. And I haven't talked about the word imperfect in Graziano's definition. I'll get to that in a minute. But before that, I want to, because that word imperfect adds a lot of layers to it, which I'll get to in a few minutes. But before we delve even further into that, I want to make sure that even the basic definition of consciousness, that is that that any brain is taking information in, it's processing that information, and it needs to do that for its own survival and all of the types of things that can mean. Let's have a quick discussion around that. So let me stop sharing this screen. I don't know should I stop sharing, because then these slides will go away. I don't know if there's a way that I can keep it on the screen while we discuss.
That's fine.
Is it all right? So I'll stop sharing, and then we can have a quick, maybe 5-10 minutes at most. 5 minutes probably. Just anybody who has questions or further ideas on this.
So folks, go ahead and type exclamation point or raise your hand in Zoom and type. Go ahead, DLJ.
Yeah, 2 issues so far. Brain's imperfect. Why brain only and not the system as a whole?
So
there are creatures that have no brains but are still processing information, right? Plants, for obviously. Sea squirt is my favorite, that starts with the brain, and then once it's settled, it then eats its own brain. So I love that one. So is it brain, or is it more to do with the ecosystem as a whole? And the second one is the word information. I need a definition for that, as opposed to data, depending which country you're in. You prefer information. So need a definition of information.
Okay, so so first I use the term brain, and so did Graziano, because we're really talking about consciousness and the types of organisms that you refer to, DOJ, which stretch our conception of what it means to have a brain and what it means to behave without a brain, or with a partial brain, or a very different type of brain. So consciousness really has to have specific features, and in a sense, it has to have a somewhat, I don't want to say the word complex, but it has to have a somewhat, the number of neurons, you might say. And again, there's no clear definition here. There's no way to define it. That's one of the challenges in this area. But we understand that there has to be a certain number of neuronal connections, which translates to a minimum number of neurons. And we're not ready to say there has to be X number of neurons, 10 million or half a billion. There's no X, there's no number yet. But that number is not very small. It's not in the tens of thousands. We know that most organisms that have aspects of consciousness, and again, the problem here is that we're talking about consciousness as if it's a known entity in itself, which itself is not. We're trying to define it. So that we're going to run into this chicken and egg problem, throughout this, and this is the reason why this is such a contentious and difficult to delve into topic, across the sciences. But I'm trying to give intuition on some of these ideas, whereas the nature of consciousness has to do with processing of information, and I'll get to that second point that you raised about information versus data, processing of information, and it has to do with the survival aspect. So those are the two things that we're really talking about that I want to get feedback from others. So when you talk about data versus information, there's different levels of extrapolation and elaboration of these concepts. We can go into understanding and wisdom, knowledge and wisdom, etc. There's different strata of these words that kind of nudge us further and further along this pathway of more sophisticated understanding of data, basically. And data, we might say, is the minimal lens through which we gather all of this. Now, data at its core is very, it doesn't necessarily have to have meaning. For example, the temperature on planet Earth, or in a particular locale where this organism happens to be, whether it's in the ocean, whether it's on land, whether it's floating in the air, wherever it is, the temperature itself, and temperature can be measured in whatever scale you have, Kelvin or Celsius or whatever, or Fahrenheit. Well, Kelvin and Celsius are basically the same scale, or Fahrenheit. So data by itself doesn't really tell us much, because the temperature by itself isn't useful. The temperature relative to a set point for an organism is really what we're talking about when we're talking about temperature for that organism. So information is this notch above data, above pure data. So I use the word information again. How far a notch above? Again, this is relative. This is a.
That's my question. Yes,
it's very subjective, and that's what we're going to have to get accustomed to this subjectivity, because the topic itself is highly subjective. So so hopefully that addresses that. And again, I realize that's not a complete answer to what you're. We can delve further into it, but I want us to move on. Just looking at this rough definition, these two rough definitions, are they adequate to help us understand what we're talking about? That's really what I'm getting at.
You make a good point. Dodge that one. Nice.
Well, actually, I know Madeline's next, but I just want to ask a follow up to that, because I think that there's I think Eckhoff has a very interesting framework. Like that data is essentially just symbols, and information. It gives you the who, what, where, when, and then knowledge would be the how. So that would be kind of a framework, and then we can get to the idea of understanding. Then that's the why, and then you get to the evaluated understanding, which is then wisdom. So, I mean, what is that type of framework? Because this is critical when we're having our discussion here, is that when we're hearing the words information or data, that distinction is important for us to understand, because data is nothing more symbols that have meaning. Then we're actually, then processing that information, and then we're able to answer again the who, what, where, when, how. Not the how, but who, what, where, when, and then the how would be the knowledge.
Right.
Is that correct?
So
is that a good way of looking at it or not?
there is, but it's actually much more complicated. So I don't want to bring too much complexity into this early on, but we kind of have to. So there's a lot more going on here. So what you both said, that we are dealing with, I don't know what word to use, but data basically. We're using data at greater and greater levels of abstraction, at greater and greater levels of meaning and context. And that's what really what we're talking about. So if you think of data, and again, we're picking words, we data, and then higher than that might be information, higher than that might be understanding, and then knowledge, and then wisdom, etc. There's a hierarchy, there's a ladder, you might say, that we've created using these words. And what this ladder connotates is higher abstraction of importance and context to the organism. So the key idea that I want us to understand here is that we're dealing with the lower level of this ladder. Okay, that's why I chose information, because it's near the lower end. It's not at the bottom. It's higher than the bottom, because the bottom, it really isn't useful for the purposes of life. Because if you talk about the temperature of the air outside, it means nothing to an organism that has to survive, because if that organism is a cold-blooded organism, then the temperature probably won't affect it much. I mean, it won't affect it, the range that it gets affected by temperature, in terms of life and death, it will be able to withstand a broader range of pure data, versus a warm-blooded creature, which will need a more narrower range of temperatures to survive, because it burns up energy. So the reason why I said information is that it's in the context of the organism we're talking about. And again, consciousness is a higher level behavior. So that's why we have to be a little bit higher on this ladder. But I don't want to go too far up, because this definition has to apply to all types of organisms. Some organisms which don't have, their ladder isn't that high. Their ladder literally stops at rung 2, let's say. Okay, there are some organisms which only go up to the level of information and nothing further, because they don't deal in anything beyond information. So that's the reason why I limited it, and I used the word information, because the definition has to apply to all sorts of organisms. Some organisms which don't have an understanding, which don't have wisdom. Insects, we don't believe have wisdom in the way that we think of it. So that's the reason why we have. There's another part of this that really is we're getting into philosophy. I don't want to go too far into it. I wanted this to be a brief discussion, but this initial part, the nature of information and the complexity with which that the brain can handle information, and the amounts of there's a slide that I have later on that gets into this. The quality and the depth of information that we get from the external world is also a part of this. When we're talking about data is like, let's use our eyes. Okay, our eyes get photons and millions of photons per second of information, of data that hits our rods and cones. But those rods and cones then translate the photons, the energy in photons, into color signals, into amplitudes, and those are coalesced and combined. There are some neurons in our, there are a lot of neurons in our retina that combine and do a very, very basic level of processing within the eyeball itself. And we're talking about organisms that have an eyeball, that have a mammalian type of eye, or even reptilian eye. They do similar things. So there's a lot of processing that happens within the eye itself. It doesn't even need to go to the brain. So by the time that information gets to the brain, it's no longer data. It's no longer parallel to the photon level of data. It's been raised to a higher level in terms of color and intensity and hue, which is the information the brain really gets. So that's why I use the word information, because it is, the brain actually gets information. It doesn't get raw data. and the amount of information it gets, the pre-processing that our brain does. I've talked about this in prior talks, but our brain filters out, meaning it leaves out a lot of information. It selectively picks certain information over others, even though some of the information that it doesn't use might be very important for survival, but through evolution, that's how our bodies developed. Our bodies aren't able to gather the best information. It basically gathers whatever it evolved to gather. And so the information that it's getting is kind of filtered. So there's a lot of other ideas around this ladder of data information, understanding, contextual, ladder that we're talking about.
Yeah, but we'll have to come back to this. I think it's kind of critical. But I want to get on to Madeline and yeah, at what point are we self-aware and things like that would be a good question. But Madeline.
Yes, thanks, Joe, and thanks, Sanjay. So this is I'm going to go with the organisms with brains for the moment, and to draw an analogy. I was just reading about and discussing a group of Native Americans, the Osage, and fortunately, a lot of their knowledge of their own history has been preserved before they got too decimated, because someone who spoke a related language wrote a lot of it down about 100 years ago. So it's fairly accurate. There's another reason why their knowledge is accurate. Their society kind of fell apart and regrouped a number of times. They had groups of elders who would work on things. And so essentially, every time they restructured, it was the equivalent of having like a constitutional amendment. It was a very important event in their culture. Are we going to continue on with a single chief? No. We're going to do a council, and we're going to have the council distributed like this. This went on for a long time, and there's a reason why they were able to keep the memory within the group. It wasn't just like people are sitting around the campfire telling stories that get passed along. They had a division of the culture into 24 clans. And so everyone in the culture knew the broad overarching history of all the different cultural changes that had gone on and the natural and philosophical implications and intertwinings. Everyone knew the broad overarching story, but only each one of the 24 clans held the particular details of some aspect of things. And so within that group, they had their own knowledge that fitted into the larger story that got passed along through the generations. And so they changed their dwelling encampments. They had a tri-seasonal system, so they would move around. And when they moved around and came together and then divided apart again and got together, they would be set up so that all 24, each encampment had to have representatives of all 24 clans in it. And so that knowledge was continually being brought together and also enacted during rituals and ceremonies. So they had both a continuous narrative through time. They had an overarching story that encompassed the whole thing without more detail than a single person or brain function could understand. And they also had specialized areas, let's say, of the brain or of working memory or of different types of brain function. So it seems like there's some analogy to consciousness. For example, if you took away the overarching story and just had a few of the brain functions, you might have what we call one of the lower animals. And so the more complex the animal, the more animal. The more complex the animal, to extend the analogy, the more clans you would add to the brain with their elaborate sub-stories and long detailed things through time, which aren't necessarily personal narratives. They might be, but they can also be things like, that's a bad rock, that's where, the predator lurked, I'm staying away, kind of thing.
Okay, yeah. So I'm not sure if you're finished. I think your microphone is muted.
Oh, yeah,
Um,
yeah, I'm finished.
So yeah, I mean, great points. I mean, there are a lot of parallels with the description you gave of the Osage, um, and I mean, consciousness. Again, it's such a broad topic. It occurs at so many different levels. The complex nature of the capturing of information that you described here, the multi-layered capturing of information over time, over clans, over individuals, over experiences, over nature. All of this happens in higher order animals. But we can, when we simplify this model or this image of the Osage, of the methods the Osage used, we start to see what simpler organisms do. So yeah, it very much applies. Thank you. I see Andrea has a hand
So
up
we have
also.
Andrea, then Mike.
Talk now. I had three things. The first one, Sanjay, I think a couple of years ago, maybe you said something that like really struck me in a prior discussion about the percentage of your body's energy that is consumed by your brain. And that relates to whether or not you're nervous or not. So that, I just really remember that sticking in my head. So I'd like it if you talk about that. The second thing is the inability of humans to process something like sight when it is enabled later in life. So I have a friend whose stepfather has a, what do they call that? The implant, a cochlear implant.
Okay.
And he's kind of a zombie, but we take him out to dinner all the time and he walks around, and apparently people who have like a cochlear implant and they have something that enables sight at a later point in life, but it's kind of like somebody speaking to you in German. If you don't know German, you can't really, the processing center is processing it, right? But you don't have the means to interpret it. And then the last, so the percent of your body is consumed by, or the percent of your body's energy consumed by your brain. The inability to process something like sight when the mechanical part of it is enabled, but you don't have the processing to understand what's happening. And then the third thing is whether or not, and this is just kind of a question, do you believe, is there an explanation for what we call intuition? So like I lived with somebody for a while that was schizophrenic, and there were things about him where he seemed to, well, for one thing, he had auditory hallucinations, which was really weird, but he seemed to have almost like a psychic sense of, like, he understood things in a different way than other people. And I'm not certain if it was, I mean, that's actually a bad example, but do you believe that instinct exists? And what is the difference between instinct and intuition? Or is there a difference, like, mechanically between the two? And I'm done.
Okay. Yeah. So these questions, I mean, they're very interesting, and I'll address one of them. But tonight we're talking about consciousness, so I'll try to address some of these to the level where it applies to consciousness. But the questions are really they're about a lot of more complicated things than just consciousness. So just the use of energy, I think you asked about that, and a while back I said, and this is a statistic you can look up, you can find, but basically there's actually multiple meanings of the statistic. So I'll try to explain a little bit. What I said earlier was that the average person, and again, the word average itself has many meaning, right? Are we talking about any age human? any mass human, the body mass. All of these things, vary based on all these characters. If a child versus an adult. So take it with a grain of salt. Averages across all of these things. Average. The average person, the average human, uses on average per day about 20% of their energy is consumed by their brain. Okay. What that means is that, and this can be measured in one of two ways. You can look at the total energy used relative to the energy per day that the person has, or you can look at the energy used relative to the energy in that instant that they have, that their body is using. And the actual number will vary, but it'll still be around the range that we're talking about, around 20%. So anyway, hopefully that answers or gives you more insight into what that means. But there's more to it than just that. It's any statistic. I mean, I work with statistics, so there's a lot more behind statistics than a single number. A single number is kind of a oversimplification, and the important side of statistics is understanding what was done, what you had to do to your large amount of data to simplify it into this one statistic, into this one number. So anyway, I'll stop there. You asked about intuition, and I think intuition versus instinct. And both of these, I mean, they're related in many ways. To me, instinct is more primal and more innate, versus intuition can be learned, and it has to do with your experiences in life. So you can change your intuition, whereas instinct, I think, is probably harder to change in terms of just pure differentiation between these two. Everybody has instinct and intuition. Now, whether it's always correct or not, I don't know if that's where you're getting at, but that's a part that is, extremely difficult to go into, because a lot of times our intuition and instinct, whichever one we're talking about, is actually wrong, even when we think it's right, or even when someone else thinks it's right. So it's something that has not been studied using the sharp lens of science as much, because whenever it has been studied, it tends not to show that the people who believe they have intuition or instinct about things, that they have it. Now, just to give a slight shift in that answer, when you talked about the person you knew who had, I think you mentioned schizophrenia, I'm not sure what. So and again, we're talking about conscious, we're talking about gathering information into our body. So people who have certain disorders of the brain, disorders of the mind, their mind and brain works in different ways than a typical person's mind or brain works. Therefore, the way they take in information also can be different. And one of the things to understand is that the average way that most people take in information is sporadically, and it leaves out a lot of information. Everyone's brain doesn't take in everything that's in the world around us. So our eyes are not seeing everything. I don't mean the noticing part. I'm saying the physical photons. Okay, our eyes are not able to pick up all of the data that's out there in the physical world around us. It can't do it, and so it has to kind of leave a lot of that data on the floor. It's picking up bits and pieces here and there, and out of that, it's making sense. It's building a model inside our brain, inside our mind. We're building a model of what it is out there using our eyes and our ears and all of our senses. That's what everyone's brain does, including the lowest organisms. But a person who has a certain disorder like schizophrenia, their brain does it in a slightly different way. So their brain might actually pick up more of the visual cues than a person without that disorder. So in that sense, they might actually have more of an instinctual understanding of the world around them. I'm not saying they will, everyone does, but it's possible that a person with certain disorders might be better at it than a person without. So hopefully that answers the types of things you're going into.
Yeah, thank you. So we'll go to Mike, and then I think we'll get back to the presentation, and maybe just finish the presentation so we stay on schedule a little bit after that. So Mike, go ahead.
I'm not sure I understand the what we presented so far in relation to what I read in Graziano's stuff, and I'm not sure I understand Graziano's stuff either. But he describes that consciousness is an emergent property of complexity, and complexity is an emergent property of entropy. where even though there's the entropy is an engine that drives this, just but it creates local areas of order, which consciousness might be. Now, there's consciousness in there's consciousness in the 14 people that are in this panel, but there's collective consciousness of all 14 taken together. There's consciousness in an infantry battalion that exceeds the consciousness of the individuals, and there's consciousness in an anthill that exceeds the consciousness of an individual ant. And an ant may or may not have a brain. It may have just a bunch of ganglia with neurons with 1 or 2 neurons at the end of each ganglia. Now, is taken with that, is there consciousness in a self-driving car, or a self-driving drone, or a fleet of self-flying drones that have been given an objective and they fall together in order, or in a fleet of monarch butterflies that are trying to migrate? Now, I guess maybe I'm asking you to explain what emergent properties are, as interpreted from Graziano and as interpreted for other people of emergent properties.
So we went into emergent properties of consciousness in I think it was last month. So I don't want to go into it again, but just, yeah, I mean, some of the things that you said connect to the topic tonight, and we do. So yeah, consciousness is emergent. It does have to do with the number of, and I mentioned this also, it has to do with the number of connections between neurons. And so not necessarily the number of neurons themselves, but it's more complicated than simply the number of neurons, because each neuron can have more than one connection with other neurons. So it's the number of neurons and the number of connections between neurons, the number of nodes in the network, you might say. So if you're talking about anthills or monarch butterflies, swarms of monarch butterflies, or a swarm of drones, or any type of entity, we're getting into the system side of system theory. So if you think of that anthill as being comprised of many, many, thousands and maybe millions of ants, I don't think they're millions, but probably tens of thousands of ants in an anthill, and each of those ants might have, let's say, 1,000 neurons, then those 1,000 neurons times those 1,000 ants will give you 1,000,000 neurons. And so those 1,000,000 neurons you could think of as a single brain. So what we're talking about still applies. It doesn't matter if the brain is dispersed across space and time. It doesn't really matter. So in a sense of what Madeline said about the Osage, it's the same concept, that the information that we're talking about doesn't have to be conceptualized all at the same time. It can be over time. It can also be over space. It can be over any set of dimensions. So, in that sense, I think these definitions still apply. The only thing that might still leave a little bit of uncertainty is when in Graziano's definition, he used the term imperfect. And I think that I'll get to in a minute. That's what I want to go into, because that's a key part of understanding consciousness and the higher organisms. So I think someone else had their hand up. Kimberly?
Yeah, we're going to move on, Sanjay. It's almost 8:45, and she's stepped away anyway. So let's keep going here. This is
all right. Let me share again. So let me just quickly talk about the imperfect part of what he's talking about. And again, he's talking about higher organisms like humans. And when we have a picture of our activity, and it doesn't have to be a picture of our brain activity, because at that point, let's say it's a child. A child doesn't know they have a brain. A child isn't aware that they have a brain and that their brain can look inside of itself. They're not aware of that. But any human, their brain is able to look inside of itself. Okay, almost from the first month after birth. I mean, from a very early time after they're born. So the ability of that brain to look inside of itself is imperfect. Okay, and it might get better. It could get better as the person gets older and becomes, you might say, wiser, or they reach more, attain nirvana or self-actualization, or their ability to understand things across everything, the world, as well as inside them, and as well as inside their conscious cognitive thoughts. The ability to understand all of those begins at a very high level of imperfection, and it only gets better, but the amount of imperfection decreases. But what he's saying is the imperfection is always there. That's the reason why we humans never reach, perfection, because our brain can never fully look inside of itself. One of the key things that happens is when we talked about free will, and almost all of the research and all of the studies that have been done in neuroscience shows that our brain concocts, it basically creates this perception that we have control over what we're doing, and it does it by kind of flipping time, or a sense of time. It plays with our sense of time by moving it forward and backward, usually moving it backward. And that's the sense of what we're talking about here, is that our conscious awareness of what our brain is doing is imperfect. So when our brain is fooling itself into thinking it knows what it's doing, or I want to move my finger, but my brain actually, the lower part of my brain actually began moving my finger even before I had a realization that I was going to do it.
Lo que tú dijiste hoy fue muy significativo.
I don't.
Okay, I got it. I got it.
So anyway, that imperfect word is very important, but it applies to the higher order organisms. So consciousness has levels. So I'm going to try to run through these very, very quickly. So at a minimum, we can think of consciousness having 2 levels. A little more practically, we can think of it as having 3 levels. Hopefully this slide isn't covered up. Anything covered up in it, or is everybody able to see everything? If you can't, then just let me know.
I can see it. I can see it. Thank you.
All right. So minimally, the 2 levels that we talk about when we talk about consciousness are what we call awakeness, and the second level we talk of as awareness. Okay. So awakeness is where our brain physically is on, and the brain. Another idea that I've talked about in past talks is that the brain isn't a single entity. The brain itself is a system, and it's a complex system of many, many different entities. And these entities, over evolution, if you think of a human, our brain is an evolved brain that evolved from lower types of organisms. So our brain has evolved consisting of multiple brains. So the awakeness part, when we're talking about it, refers to which of those sub-brains that we have which are awake, because not all of our brains need to be necessarily awake at the same time. So when we're talking about the levels of, so what I'm doing here is I'm defining at a minimum, 2 levels of consciousness, and each of these levels will have sub-levels within them. So when we're talking about awakeness, the sub-levels of awakeness will depend on which parts of our brain are awake. Is our entire brain awake or not? Or is only one part of the brain awake, the lowest part of the brain, which we call the brainstem? If only the brainstem is awake, then the person is at the lowest level of consciousness that we have defined. Okay, on the order of what very, very simple organisms, not plants, but insects, and even simpler than insects, those types of organisms have what would happen if a human, the lowest part of the brainstem was only active and nothing else in the brain was active. That's the type of consciousness we'd be talking about. And we don't think of that as consciousness, but from a scientific perspective, it is, because the brain is awake. And anything below that would be a coma, and anything below that would be, the person would be brain dead or literally dead. So, we start with the level of consciousness where we're awake, where a part of our brain, the brainstem alone, is awake and nothing else is awake. All right. And then the second category has to do with awareness. And that's where we have a subjective understanding, meaning our brain has a subjective understanding of the things the information that it's dealing with. It doesn't have to have an understanding of itself. Okay, and we'll get into this, that if we take this awareness level and we stratify it into multiple other levels, then we see that consciousness of awareness also splits up into multiple types of awareness consciousness. And then when we combine these together, we have a much larger set of levels. And I'm going to just say quickly that there's a third level. Third level is actually part of that second level. Okay, it's not a third level, but it's part of that second level. But when we humans talk about consciousness, we're really talking about this third aspect, which really is just a hyper awareness type of behavior, that we are aware of not only our experiences on our brain, but we are aware of our brain and its ability to think about itself and its ability to think through time, think in the future. So it's a very sophisticated type of awareness. But most humans, when we talk about consciousness, we're talking about that third, but I want to clarify it's simply you might say the highest level of that second category of awareness. Okay, so quickly, we're talking about the first one now, awareness at the physical level. Level depends on which parts of the brain are active or on. Subjectively, it's measurable in neurology and in medicine. It attaches an importance to feedback. So it assumes that the person who we're trying to assess whether they're conscious or not, that they can respond in some way. There's no physical impediment that allows them. So for example, if they can move their finger, if we're asking them to move their finger, they physically have the ability to move their finger. If they don't have the ability to move their finger, but we're asking them to move their finger, even though they're conscious of it or they're aware of it, they may not, and they're awake, they may not be able to move their fingers because they don't have the physical ability to move their fingers. So there's a little bit of issues around that. So the clinician's expertise in this is also critical in this, that they have to understand that they may be using a tool or a method to assess which is flawed or which is biased. So therefore, there's a limitation to how much we can do here. But basically, the subjective level of awakeness is very important. Now, let me just give in this. There's another concept that's very important here that I talked about a long time ago, but I'm going to bring it back because it's very important. And this has to do with how our brains evolved. And I mentioned this briefly, but I'm going to just show a very quick animation or a slide of it, a very simple slide of it. And our brain, basically, the human brain, primate brains actually, have what we call 5 different encephalons, regions, large regions of the brain. Okay, the lowest region is the myencephalon. Next region is the metencephalon. I talked about this, months and months ago. The mesencephalon, the diencephalon, and then the telencephalon. So from right to left is how our brains evolved over time in terms of evolution. So the smallest, most simple organisms only have a myencephalon, and the most complex organisms like primates and larger mammals have all 5 of them, especially the telencephalon. So the telencephalon, telencephalon correlates to the cerebrum. Cerebrum is the brain cap, you might say, what we think of as the brain. When we humans talk about the brain, that's the part we really talk about, but there's a lot more underneath that we kind of ignore. The medulla oblongata is a part of the brainstem. The pons is another part of the brainstem. These 2 parts exist only in certain organisms, the simplest organisms. The cerebellum is in a lot of organisms that have sophisticated motion because the cerebellum is primarily with balance and motion. Diencephalon is what we think of as a limbic system, and the cerebrum is the thinking cap, the thinking brain that we have. So these 5 regions are really important. So when we're talking about consciousness, which of these parts are on and which of these are off? That's an aspect that's important. And when we're talking about the higher level of consciousness, when we're talking about not the awakeness, because awakeness has to do with which of these are on or off. The awareness means that all of these have to be on. But then how aware are the last 2, the leftmost 2, the paleomammalian cortex and the cerebrum? How aware are they? How much information are they processing from the external world and from the internal world? And what are they doing with that information? That affects the level of awareness that we have. Level of conscious awareness and sophisticated consciousness arises from those 2 regions of the brain, primarily the orange one, the cerebellum, which is the main brain that we have. Going back to the awareness part, there are two great. I'm not going to actually, let me skip these. The Glasgow scale and the Grady scale. These basically describe measurements that we have, ways of measuring a person's awakeness level. I'm not going to go into because we have to get into. I want to get into some of the further things. So awareness levels depends on which parts of the brain are operating in power. So the key here is in the awakeness level. This bullet talked about the level depends on which parts of the brain are on. Okay, but in awareness, it's not simply whether they're on or not. They have to be on. All of the levels or most of the levels are on when we're dealing with awareness. but it has to do with which parts are operating and cooperating in parallel. This is the key, that these different parts of our brain have to cooperate, and actually cooperation also means competing, because cooperation, competition, cooperation, both, it's a two sides of the same coin. So both activities, sometimes different parts of our brain compete with each other, but they have to interact with each other in parallel. That's the key idea for awareness. This is not measurable and probably will never be measurable, and qualia is an aspect of this. I'm not going to go into this. I've talked about this in past. If somebody has a question, we can go into a little more, but qualia is an aspect of consciousness, that of higher level consciousness, especially of awareness. It's a subjective understanding. It's a subjective, purely subjective feeling of what we're experiencing. Now, I'm going to combine these two broad levels into the lowest level of the ladder that we talked about at the beginning. So which brain, lucidocephalons and the lobes, which regions of the brain are on. At the lowest levels of consciousness, the higher brain regions are off. Okay? The brainstem keeps us minimally alive. It keeps us breathing. It keeps our heart pumping. It reduces our digestion, and we don't do much else. We don't do any thinking. We might not even have an awareness of where we are. We might be asleep or, in a comatose state. So at the lowest levels of consciousness, the brainstem is there, and not much else is working. The eyes, they might do nothing, meaning the information the data that's gathered from the eyes and information that's sent to the brain might be none to it might be minimal. So the eye is really not doing any locating or searching of anything in the visual field. Moving our body. At the lowest level of consciousness, the organism probably isn't moving its body much, or isn't able to move its body much, because to move your body, you have to have an awareness. You have to be able to feel the earth that you're standing on, or the something that you're pushing your body against to circumlocate. Understanding and interpretation of our environment would also be much, much lower at the lowest levels of consciousness. At the higher levels of consciousness, there are actually much more sophisticated things that happen. So, and this is what is going to be difficult to delve into, but what we're doing is we're gaining awareness of the external information as well as internal information from within our body and within our brain and within our mind. So the external and internal information, we're coalescing those, so more sophisticated understanding, also of the physical world, but also of a metaphorical understanding. So this, in a nutshell, is what defines the higher orders of consciousness. The extent to which we're dealing with external and internal, to the extent to which we're dealing with not only physical, but also metaphorical and metaphysical concepts. These define, or these kind of help us to assess where along this chain of higher level of consciousness that an organism is. So along this chain, you could say that the simplest organisms are aware, meaning they can perceive and they can have a certain set of understanding of the environment around them, and that's it. Okay, but not of their own body. They only sense that there is an environment around them. They don't even sense that they have a body. At the next higher level of consciousness, that organism would be sensing that they also have a body, and that body is part of the environment. Okay, so it's integrated view of the world. And then the next level of consciousness would be that not only they realize that they have a body, but they realize that they can control their body. Okay? And the next level of consciousness, next higher level of consciousness, would be that they realize that they have a mind, not sophisticated mind, just that they have a mind, that they have feelings, or they're aware of having a mind. And this doesn't mean they're aware of other organisms having a mind. That's a theory of mind, which will come later. That would be later. And so if you look at this gradation further down, thoughts come into play, and then ideas about time and the future and the past, that comes into play. And then at the lowest level, I'm going to move this so that you can see. So at the lowest, or sorry, on this slide, the lowest level, but the highest level of consciousness, we're recognizing that we can feel, we can think, we can understand. And this is where we talked about the difference between simply taking data versus information versus having an understanding versus having a more sophisticated conceptualization of what it is, and then having at the higher level wisdom, right? So recognition and having wisdom would be at the higher level. And then at the highest level is what we believe only humans can do, or maybe some primates at a very simple level, they can maybe do this. At the highest level is that they can think about their own thinking. They can understand that they are thinking about thinking. And that is a very sophisticated type of consciousness. So this kind of hopefully gives a gradation of greater and greater and greater sophistication of the types of information that the brain and the different parts of the brain all together are using. And all of these information are basically passing from brain region to brain region. And there's a coalition happening with all of this information flowing within the brain. And this realization recognition happens in specific regions of the brain, primarily what we in humans we call the prefrontal cortex. That's where a lot of recognition and understanding happens. So for the higher levels of understanding that part of the brain region, today it's believed that that part of the brain region is necessary for a lot of these highest levels of cognition. So just to summarize this, consciousness, it gives us increasing awareness of external and internal and the physical and metaphorical types of information. And also, let me just, what I'm doing in this slide is in the previous slide, each of these bullets can be extrapolated into 3 more sub-bullets. So if you think about these bullets, what is it about? 12 bullets, roughly. Each of these 12 bullets can be extrapolated into 3 more sub-bullets. So you can end up with about 36 bullets of the higher order levels of consciousness. Now, I don't want you to say that Sanjay said 36, okay? What I'm saying is a large number, okay? So for example, the concept of this first bullet of our environment, that the organism is gaining information about its environment, about the things around it, but not of itself, right? So it's gaining information about its environment. So the types of information it gains about its environment has to do with the existence of information and the amount of information. So that's what I talked about earlier, that our brain doesn't capture all of the information that's out there. It can't. And that's kind of limited by how evolution formed our senses and how it formed our body. But the existence and the amount of information that actually goes into our brain and the different regions of our brain, that is important. That's one of the aspects of this. The second aspect is the quality and the fidelity of information. So for example, not just the amount of information, but you might say the resolution. So we know about visual information having a resolution, right? Like, is it 4 megapixels or is it a 4K camera, or is it only a 4 megapixel camera, right? There's a huge difference in the fidelity and resolution of images between those two types of cameras. Similarly, our senses have a certain fidelity and quality to them. And depending on that, the amount of information that the brain not only can capture from the senses, but it can actually process. Because if the brain isn't large enough, it doesn't have enough neurons, it doesn't have enough connections, you can throw all this information into it, and it won't be able to process information because it doesn't have enough neurons to do the processing. So this is the reason why a lot of these things are tied together. The size of the brain directly affects, and the size of the connections between the brains directly affects the level of consciousness, because the ability to process massive amounts of information is limited if you don't have if the network isn't that large, if it doesn't have enough neurons and connections. So because the world consists of high fidelity information, but the brain is limited in how much you can process. And the third thing is the intensity of our feelings. And this is the quality part of it. The intensity of our feelings and their interpretation of what that information is. So for example, when I describe temperature, an organism, a lizard sitting on a rock, feels the temperature. And what that temperature does to it and how it makes it feel and the intensity of its feelings, well, a lizard probably doesn't have the type of feeling of warmth that we have. It does have a sense of feeling, but it doesn't necessarily have this type of sense that we have, where we associate, at the beginning of this talk, we talked about warm rain and cold rain, which is about temperature of weather, about rain. We have very sophisticated ideas around temperature and the comforts that we derive from temperature. But the lower organisms don't really have these sophisticated senses. They don't think of warm rain. They think of is it comfortable or not, in a simple sense. So if the lizard is comfortable on that rock, it'll stay there. If it isn't comfortable, it'll move around until it finds another place that is comfortable. It has a much simpler sense of intensity. Intensity might be good or not so good. That's it. Whereas we have much more higher gradations of feelings and intensities and interpretations around the information that our brain gathers. So at the higher levels, these 3 sub-bullets add a lot more depth and sophistication to consciousness. So let me pause here and just to make sure that they're everybody's caught up. And then I'm going to close out with the last section, which I'm going to talk about the basal response, which is one of the things that will help us to elucidate why, how conscious, how important it is, and So any questions? Just if you have questions directly related to what we talked about, please, I'll address it. Otherwise, at the end we'll have something where we can capture.
So folks, go ahead and raise your hand in Zoom or type exclamation point in the chat. Really quickly, that last slide actually was very interesting to me, Sanjay, where you're talking about the intensity of feelings. And I think that that's an important point. So where does the role of language come in to consciousness? Because the reason I say that, the intensity of our feelings are invoked often by things like, the way we phrase or frame certain questions, or the way we even frame information itself. So that actually impacts our reaction to it. So how does language then relate to these higher level states of consciousness?
So so language is specific to communication, right? So we're not talking about the information only within that organism's own brain. We're talking about the information that that organism can convey to others, or it can use to work on the world. So let me give another aspect of language, which a lot of people don't realize, but it's very important in neuroscience, is that language is a tool. I think most people understand that language is a tool, but it's not simply a tool for communication. It's also a tool for conceptualization and understanding within the organism. So for example, if you think of a dog or a cat, okay, they don't have language the way we humans have language. They do have language, it's much simpler. And you might even say they have a vocabulary through which they can communicate, or they can understand people, talking to them. But before we get into communication, in input or output into the brain, before we get into that, the dog has to have an understanding. When it smells something, it has to have an understanding or realization of the smell that its sensory organs are detecting. Okay, and how is that smell, or its realization of that smell, how is it encoded? Now in neuroscience, we think of it as there's a lower order language that is encoded in, but in colloquial speech, we don't think of that as language, but that really is a language. It's encoding, it's the mechanism of encoding of information within the brain, which follows patterns. So for example, if the dog recognizes the smell as a smell of its owner, of its human, right, then that will light up certain parts of the brain. And just the same as if the dog recognizes, or a person recognizes the name of their owner or the name of their loved one, right? If you recognize their name, it lights up a certain set of regions. And in the dog, the odor of that person would light up the set of regions. So in a sense, the encoding is identical to what happens with language. Okay, so that's important. So I'm going to include that as part of the answer to what you're asking, is how does language affect consciousness? And so language is central to anything dealing with awareness. Okay, the higher levels of consciousness, language is fundamental to it. And again, I'm talking not only of language as in spoken or communicative language, but language as in stored language, the ability to store information in the brain. It has to be stored in a sort of encoded language. And it's not encoded in human languages, it's encoded in very complex. We don't have a way of understanding how language is encoded in any animal brain right now, but it is encoded in some ways, it's very complex ways. So that's, at that level, if you understand that way, all conscious ideation, and I use the word ideation very loosely, it doesn't have to be complex ideation, it can be very simple ideation as in a smell, right? It can be the smallest organism, a rat scurrying along, or a cockroach even. A cockroach doesn't have a nose, but has antennae, which picks up basically molecular signals similar to what our noses do. So a cockroach scurrying along, it's going to get information from its antennae. And that information will send information, and that information will be represented within its brain. That representation is in a language form. it's a very, very rudimentary language form, even within humans, even within cockroaches, but it is a language. So the consciousness that we're talking about, it has to be encoded in language. So at the simplest level, Joe, that's, I think, hopefully that addresses kind of what you're asking.
Yeah, it is. It does. I mean, words are almost boundaries. They are delineations, and what those delineations then allow us to do is to apprehend. So yeah, so essentially that's what we've kind of covered that a little bit with the Bucky Four series. So next up we have DLJ followed by Vanessa.
Right. Yes, excellent. I love the lists of the levels because there's a couple I hadn't got, so I've scribbled those down. Back to the definition of information, you used the word meaning, and you used it a couple of times. So I picked up on that because you're hinting at signal theory there, right? Yes, because it's about attaching, you know, you're right. Previous session, I think we talked about signal theory. For people who are unfamiliar, cues, signals, coercions. The cue being if you're in a house and the toilet seat is left up, you know what? A man's been there, right?
There's a male who probably lives there, yeah.
Did they intend to send that as a signal? Probably not, right? Whereas a signal is usually like a dog peeing on a tree. That would be sending a signal. And then, of course, we are attaching meaning. So I was sort of waiting to somewhere in the list that you were going to say part of consciousness is the meaning attacher. And when you had your list of higher levels, your first one, and I can't read my own handwriting now, but it was something like passive sensing of internal, external stimuli, but not aware that we're doing it. I think I was writing. Yeah. Thought to be the situation with insects. If you've got meaning, in quotes, meaning is part of your definition of information, you're implying therefore that insects can do the meaning thing?
So let me explain. So again, at the beginning we talked about this ladder of data, okay, and higher levels of data abstraction. Meaning is on the higher end of that ladder.
Oh yeah.
Okay? But it spans the ladder. So a very simple organism like a cockroach still will make what we won't call it meaning, but to them there'll be a meaning associated. So for example, if their antennae are picking up certain molecules in the air, and those molecules represent a chemical that they like, right? They will, using language that Joe referenced, there will be a conceptualization that occurs in their brain, which gives them a realization of the direction to go in. Okay. Now that realization won't be like you and I have. Okay. We won't have a cognitive understanding that I'm smelling something, I'm sensing something that I like, and I'm going to go in that direction. They won't have that. A lot of this will be automatic, where it activates clusters of neurons, which associate other clusters of neurons, which eventually lead to its legs, to its feet, which cause it to move in a certain direction. Yeah. It's not aware in the sense that we are. It just automatically kind of does it. It's almost like when we subconsciously, when we're driving and we're not realizing that we're driving, or we're taking turns and stopping at red lights and doing all kinds of sophisticated things when we're not conscious of it, same thing that these organisms are doing. There's meaning there, but the meaning is not at the highest level. The meaning can also be at the lowest level. But when we're driving, it's still at a relatively high level. But yeah, that meaning, it's relative to the organism. Think of meaning, the word meaning, think of it as the maximum capability of that organism's brain. Okay? Relative to it, it's on near the higher end of that scale. That's one way to think of meaning.
Yeah, I'm cool with that. That's good. I've got a follow-up thing, but I'll wait until after you finish the presentation because I haven't heard it yet, but you may be covering it later.
Thank you, DLJ.
I mean, this is going to be exhaustive. I'm not going to be exhaustive. I mean, so anyway, that's.
So, you know what, let's go to Kimberly first. Vanessa, we'll come back to you. I asked Kimberly to lower her hand last time because we were going a little bit long, so I'll give her a chance now.
So mine is not so much a question, but a comment. And you alluded to it earlier on. So my mother passed on recently. And I have a good friend, a longtime 3M person, and I have a good friend who's a chemical engineer, extremely bright. And I found out just a couple of years ago, he's on the autism spectrum. He admitted it to me. I could tell he was like always a little bit off, but I didn't say anything. And then when they shared with him issues with my mother passing on recently, he immediately emoted the feelings that I had dealing with my mother's passing. And I don't, he doesn't know my mother. So I think there's something there with people that are on the autistic spectrum. They see things that we do not see from a consciousness perspective. That's just my comment. So.
Yeah. No, that's very true. Yeah. I mean, in terms of neurodivergence, so many types of brains, most brains don't see, no brain sees everything. That's the thing to understand. And so if you think of in front of you, 50 different things, right? And you have 50 different people in front of you. Everybody's going to see a different set of the combinations of those 50 things. Everyone will see slightly different versions of that. That's the way the neurodivergence is. So there's no right or wrong here. It's not that some people are better at observing or seeing or other people are worse. It's not about that. We're seeing things in different ways and we're picking up different signals from the world around us. But yeah, good point.
Go ahead, Vanessa.
Okay, it's possible you may be doing this with the next section, but the one paper, I only had a chance to do that because I couldn't watch the videos. It mentioned like for a degree of a coma, and a lot of that, relies upon painful stimuli, but altered states of consciousness where maybe you aren't so much in a coma, but let's say someone that's in shock, maybe very hyper-focused, but maybe they can bring back, let's say, the smell or something that was happened, maybe not the complete environment, or someone that is experience a lot of adrenaline that may not experience the pain. So how does that all fit in there? Because like I said, you may use these things for the coma thing that someone doesn't respond to the pain, but simply because maybe they are in a state of shock or the adrenaline is like through the roof. So it's affecting, I guess, how that senses the pain might be perceived, or maybe it's felt, but not, there's no outside reaction to think, oh, this person is responding to the pain. If that makes any sense here.
Yeah, I understand what you're asking. So, pain response, when people are in comas, it's actually the, this is a very complicated area. I'm trying to think of how to simplify. So people in comas, it's not that there is no adrenal response or that the neurotransmitters aren't being generated. They are being generated, but either receptors outside of the brain as well as receptors in the brain, especially in the brain stem, because that's the part that's really the most active in a person in a coma. They don't respond to those neurotransmitters. That's what happens. It's the neurotransmitters are being generated. Sometimes they're being overexpressed, much more than they normally would be, because they're not responding. So the body actually generates more because it doesn't understand why the person is not reacting to it. So it is being generated, but what can cause comas? It's very complicated. But anyway, so in the next part, I'm going to go not into coma, but I'm going to go into the vagal nerve, but which is an aspect of it's not about coma, but it's very low level processing. So just you might. I think I've answered what you said, but you might hear more in that part.
Yeah, Sanjay, there was like a set of levels in the paper, I believe, right? And there was a grade 5 scale for pain. Right. Pain, you could not feel pain in that. So maybe are you going to be going into that?
No. Okay. Those all have to do with the physical, the awakeness side of consciousness. Those are the lower levels of consciousness. Okay. And so that, I can go back to the slide, I can show it, but I skipped it just in the interest of time. There are primarily two scales that are used in neurology and the medical field. What's known as the Grady scale and the Glasgow scale of detecting a person who is in a coma or higher than in what stages, and they have to do with the awakeness aspect of consciousness, not awareness. And both of those scales look at aspects such as if the person has any kind of, if they process input and they can respond or not. So you give them a verbal cue, do you hear me? And if they give some kind of response or move the finger or they blink their eye or something, that, or if they don't do that, then that means that the highest levels of the brain are not functioning. Then you go down a notch. Then you might use pain stimuli. And below that, you might use just touch stimuli, if they can sense very slight rubbing or tickling. So that's what these skills are about. They're trying to differentiate which parts of the brain are off. Because at those lowest levels, when we're talking about a human who's in a coma, major parts of the brain are literally off. They're not working. What I mean by off, it's not that there is no activity. There is activity, but it's not coordinated activity that would happen in a normal functioning brain. These brains are effectively disconnected in a sense from the other parts of the brain. They have minimal activity and they're not really processing in the way that it needs to for that person to be able to function and react.
And the level 5 would be the Glasgow scale, I believe.
Well, so again, each of these skills have their own levels, and they're arbitrary skills that two different teams came up with. They don't have a direct overlap. There is some overlap. And again, they only have, these skills only affect the lowest level of consciousness, the physical level of consciousness, what I termed awakeness, whether a person is physically awake or not, whether their mind can be awake or not. That's what they have to do with. And that part is not as important for the talk. It is important overall because it shows that consciousness has many, many levels. But when we're talking about human consciousness and the sophisticated consciousness, that doesn't apply as much because most everyone who is conscious at a human scale is not in a coma. They're awake and they're able to interact.
Okay, and Andrea, could you actually wait until the end so we can make sure Sanjay gets through his slides in order to thank you. Appreciate that. So that's the third part of the presentation.
Okay, so thanks, Andrea. So let me just get the slide. Okay, so the last section I'm going to touch on is something called the vagus nerve. And this is, it's a technique that I'm going to use to demonstrate, to tie together a lot of the ideas that we talked about tonight. And just to give you a little understanding of what the vagus nerve is and why I picked that specific nerve. So our brain, basically our central nervous system, okay, and again, we're talking about higher animals, reptiles and onward, or most of the more complicated organisms, they have a central nervous system which consists of the brain and then the peripheral nervous system. Okay, and the peripheral nervous system is the spinal cord. Okay, now the brain itself, believe it or not, has 13 different very important nerve bundles that come out of the brain directly, and they don't go into the spinal cord. So when we think of the peripheral nervous system, most people don't realize that there's more to our nerves, the diaspora nerves in our body. There's more to it than just the ones that come out of the spine. There are also a lot of nerves that come out of the brain directly. Many of you know of the optic nerve, right? The optic nerve goes directly from the brain to the eye, to the retina, and there's two of them, one for each eye. And all of these, these are known as the cranial nerves. There are 13 cranial nerves. Now, throughout the last roughly 150 years, we thought of them there as being 12 cranial nerves. Recently, in about 30 years ago, people started believing there's a 13th one. So now it's accepted there's 13 of them. One of these, the 10th one, is called the vagus nerve, and it's very important. Now, all of these nerves, none of them go into the spinal cord. Most of them go in near the head and shoulder regions. But one of them, the vagus nerve, goes outside of the brain region, outside of the skull, outside of and into the thorax and into the gut. And it does not go through the spine. And it's one of the longest nerves in our body. It's not the longest, but it's one of the longest nerves. It's a very strange type of nerve because it basically goes, and again, it's a set of fibers, it's a set of bundles, not a single nerve. It's hundreds and hundreds of nerves. All of these individual fibers go to different parts of the viscera, different organs within our body. And there are two parts to the vagus nerve. One part is which is called afferent and efferent. So it collects signals from the body and it sends signals to the body. So it has both types of nerves. It has signals that send into the body to make something happen. It has other nerves which collect information from the body, which tries to figure out what's happening in the body. And the vagus nerve has its proliferation in many parts of the body, not everywhere, but in many large parts of the body. And if you look at this, you'll start to see that the way the vagus nerve and actually all of the cranial nerves, the way all of these cranial nerves developed in animals, from the simplest animals to the most complicated animals, they developed similar to how in evolution we developed in terms of sophistication. So the simplest animals don't taste their food. Okay, the simplest animals don't even chew their food; they simply swallow it. Okay, so one of the earliest types of cranial nerves that developed in all organisms is a nerve which allows them to detect if there's food that's in their body cavity. So for example, if you think of a hydra is like a hollow cylinder. Food comes in, and when the food comes in, it kind of does, its tentacles kind of close in and it kind of constricts itself and starts the digestive process. Hydra is one of the simplest organisms. It doesn't really have a brain, but it has nerve cells. So in that organism, you can think of a cranial nerve as detecting, is there food inside of it? And if there is food, that cranial nerve causes it to constrict its body and start the digestive process. And there might be a few other cranial nerves which connect to the part that does the digestion to sense when the digestion is done. Okay, so the cranial nerves are these types of nerves which deal with very low-level behaviors in our body. Okay, and as you go through the evolutionary scale of how we went from hydra to a more sophisticated organism, and again, we're dealing with multicellular, all of these, but to more sophisticated, to organisms which actually have a jaw, which can chomp and chew on food, to a more sophisticated organism which can not only chew on food, but which has a tongue which can taste food. So the organisms which have a tongue which can taste food, they have another cranial nerve which is more advanced, which gives them the ability to taste. But the lower level organisms don't have that cranial nerve. They have fewer cranial nerves. So again, all these cranial nerves developed over millennia, over hundreds of millions of years, not millennia, literally millions of years, parallel to the sophistication of the organism. And so we are very sophisticated. So we have roughly 13 cranial nerves. And the vagus nerve is one of those which has been around since very early because, and these numbers in terms of the 1, 2, 3, 4, 5, the larger numbers are the oldest ones. So number 13, 12, 11, 10, these are the oldest ones. So the vagus nerve is one of the oldest nerves that we have, organisms have in terms of evolution. So the vagus nerve does a lot of the things that are core for almost any organism for it to live and function. So the vagus nerve's purpose is to keep the body alive and to keep very rudimentary things happening like digestion, like respiration, like cardiac cycle, keep the heart pumping, things like that. So it regulates, so it's a part of the parasympathetic nervous system. Even though the parasympathetic nervous system, most of that goes through the spinal cord, this is one part that doesn't go through the spinal cord. It goes completely separately, but it's still considered part of the parasympathetic. It regulates specific organs in our viscera. It's a part of so the parasympathetic means that it basically kind of slows down or calms parts of our body. And it has a very loose understanding of our body state. So what I mean by this is that there's very little information. I wouldn't even go to use information. This is a case where you need to use the term data, okay? That it collects data from our body. And it collects very little pieces of data from our body. For example, one of the pieces of data that it collects from our body is there food in our esophagus? Okay, and if there's food in our esophagus, and it collects another part of data, is the food in the right place in our esophagus? Meaning, is it near our trachea, which is where air goes into our lungs? Is it near our trachea or is it away from our trachea? Almost binary, like yes or no. It's either near our trachea or it's not near our trachea. If the food happens to go near our trachea, the vagus nerve causes us to have a gag reflex or a choking instinct. Okay, and again, it operates at the brainstem region. It doesn't go into the higher parts of the brain. So all of this happens at the brainstem. So the vagus nerve is doing a lot of things that even if you're in a coma, you would still have these types of functions happening. So, and it uses very little information, like I said, bits. So for example, there is something in our trachea, or is something outside of our trachea in the esophagus, that type of information. Another thing that it does not go through the spinal cord, it takes information from the body and also sends information from the brain to the body, to specific organs. Overall, it helps to regulate our homeostasis, the stability of our body, the comfort of our body. And it can affect calm, our heart, lung, vital function, etc. It's antagonistic to the sympathetic nervous system. Now, I'm saying all of this because I want to get into a very specific type of aspect, which is the vasovagal response, vasovagal activity, which happens in a very specific situation. And I'm going to tie that into more complex behavior in our brain. Because the vagus nerve normally operates at the level where we're not conscious. It does things we don't even have to have conscious. We can be asleep and it will do things. For example, you can literally choke. People who have sleep apnea, they literally can start choking with their tongue, or fluid or something goes into their epiglottis, lower regions of their esophagus. So it doesn't require higher brain function at all. Now, one of the things that happens is that there is I need to switch for a second. So vagus nerve. So this on the diagram on the left shows this shows 12 cranial nerves. This one here at the bottom here is the 10th one. This is the vagus nerve, and it basically goes to the body. It does go into the larynx and it does go into the neck area. There's a lot of activity there, but a lot of it also goes into the rest of the body. All of the other cranial nerves don't go into the body. They stay in the head area, the shoulder area. They stay the upper area of the body. This diagram on the right side shows, this is a picture of the brain stem region, basically, okay? And it shows that all of these cranial nerves emanate from and end into the brain stem region. They don't go anywhere deeper into the brain, into the more higher parts of the brain. They don't go there at all. So all of this behavior arises out of the brain stem, okay? Now, let me pause here. I have a video that I want to share, and I'm going to, let me see if I can pull this up. And I'm going to describe this in a minute after we watch the video. I think I want to make sure I enable the sound so that you guys hear this. Okay, so what this video is actually, before I start the video, let me say that there's something called syncope. Okay, and if you read the description of the talk today, syncope is a situation where a person faints. Literally, it has to do with fainting. Okay? And the normal situation where syncope occurs or fainting occurs is where there is some type of disorder, or there's something wrong with the body itself. There's a disorder in the body, either in your heart, in your cardiovascular system, or in your respiratory system, or the system that regulates your blood pressure. There is a problem in your body which doesn't maintain the tonacity of blood flow to the brain. And when blood doesn't go to our brain, we faint. We faint very quickly. And the vagus nerve is one of the nerves, one of the main nerves that's responsible for doing that. And so when people have a disorder in their body, either in the vagus nerve or in any other system of their body which regulates their blood pressure, then they can faint. They can faint at different times, different situations. Now, that's one side of syncope. But there's another side of syncope which is very unique. And that's the part that we're going to talk about, and the video talks about. And that is that you can actually have syncope occur based on your emotional state. Okay? And the title of the talk, I talked about emotional fainting. Okay, and that's what this is. It's actually the vasovagal response, or vagovagal syncope, refers to fainting based on the emotions that you have. And emotions occur at the higher areas of our brain, not in the brainstem. Emotions happen at the higher. So an example I'm going to give is that something that most people will be able to relate to. And I'm setting this as a setup for the video. We'll watch the video in just a minute. But many people can relate to the idea that if you watch something queasy, like you watch a surgery happening, which is really bloody or gory, or even if you watch a movie, some people who watch a movie, there's a lot of blood and gore. It makes them uneasy. It makes them queasy. And in some people, they can actually faint from it. Okay, they can faint from the queasiness of it. And that directly happens because of the vagal nerve. The vagal nerve is what causes that to happen, but the vagal nerve causes it to happen only because the emotions in that person are so strong. And again, our emotions appear and exist in our cranium and in our subcranial region. So basically, the emotions that are in the higher levels of our brain. So if you remember, there was a slide that talked about 5 different regions of our brain. The brainstem is the lowest 2, or you can think of lowest 3, but you really it's lowest 2. The vagal nerve is in the lowest region of the brain, and emotions appear in the highest 2 regions of the brain. So those emotions in the highest 2 regions of the brain somehow make it all the way down to the vagal nerve, into the lowest region of the brain, and it causes it to do something wrong, which causes the person to faint. Okay, and this is the process that I'm describing, and that's a highly unusual thing because that almost never happens to us normally. But this is something that happens, and it can happen to most people. And in this video, they trained regular people who don't have any medical condition to force it to happen to them at will. And it's not important how they do it. What's important is that there are several things that can happen, and then the discussion around that of why that happens and how that ties into consciousness. I'll go into that. So what the vagal nerve does is that these emotions at the highest levels of the brain in our cerebrum are so intense and so troubling. And again, the key word here is intensity. Okay, remember one of the slides that I had to do with intensity of information. So the feelings are information. So the feelings are so intense that those intense feelings, that intense information actually makes its way into and affects and impacts the functioning of our brainstem. When we're fully functioning as a person, we're fully functioning in the real world, and it affects and disrupts our brainstem and makes the person faint at will. So here's the video. Let me start the video. And this video, I'm gonna run it for about a minute because it's probably copyrighted, although it looks like it's pretty old, but still, I don't want to run too long. So hopefully everybody can see parts of the video here. Is that visible? I haven't started yet.
There's the...
Yeah, at the top, there's going to be a banner. I don't know how to get rid of that.
Kind of visible, I mean, I think.
Yeah, that's not going to,
okay,
it's not going
so
to interfere. So I just stopped. I just started it. So here's a person in wearing the shorts, and they basically made themselves to faint. Okay, and this is the vagal nerve, which made them faint. And what you're going to see is that there are many people who are going to do this over and over. You're going to see different response from each of the people. Their bodies do different types of things. But in some people, it actually can cause epileptic type of seizures also. But depending on the type it's complicated, but it depends on what exactly is in that person, their physiology, the memories that they have. This person fell in a different way. Their knees are still bent. And you'll see that this is not symmetric. Their body was not symmetric. The arms were not doing the same thing. This person, it's a little more symmetric. The arms actually are moving, they're twitching. There's different types of behaviors that are happening in all of these people. Okay. And the video goes on. It shows a lot of different types of syncope that can happen in people. I'm going to pause it.
Only 10% of the subjects lay motionless during syncope.
This person is completely motionless, and it can that happen. So there's many types of syncope that happen. So let me pause it here, and to stop sharing here. And so hopefully everyone understood what was happening in the video. If you didn't understand it, I can explain it, or you can ask questions around it. But basically what the first person did, and they didn't show this each person, but each person was trained in how to force the vagal response to happen and force a syncopic failure, basically force them to faint. What you saw the first person do was they were sitting down, they were doing certain things, and then they stood up. And there was another person monitoring them. They were kind of helping them, guide them. There was a medical person who was monitoring them to make sure they don't get hurt, and there were mats behind them, so they fell on a mat. And this was under study protocol. They were being studied for this, but each of these people were able to basically make themselves faint at will. Okay, that's the key part. And the reason why is because in that case they weren't using emotions, but they were using another part of the vagal response, which it works the same as emotions. But somebody who has a strong emotional response, like either a queasiness or something that is extremely distressing, it can cause a lot of strong emotions. And those strong emotions, like I said, will go into the basal region of your brainstem. it will activate, actually it will inactivate the vagal nerve, which will cause the blood pressure, which it's regulating the blood pressure. So it will cause blood pressure to drop very, very quickly within about a second or 2 seconds. So very quickly, relatively speaking, the person faints. And it's a temporary loss. So they quickly recover within seconds. You know, they didn't show it in the video, but within about 5 seconds, most people recover, and a lot of people recover even faster than that. But it's temporary in all cases, because the vagal system also, it recuperates itself after a few seconds, after, you know, whatever caused it, after it recovers. So what I'm going to describe here is the aspect of the cortical part of the brain, which is important in consciousness. Okay, and I want to tie that into the higher order thinking versus low order thinking. Remember that the vagal system is extremely low on the consciousness scale. It's at the level of awakeness. It's not awareness, it's a level of awakeness. But awareness of something distressing can cause us to become not awake, can cause us to faint. That's what syncope demonstrates. And what I'm going to do is I'm going to describe another aspect of this, is that most people have heard of the fight or flight response. Okay, I'm sure most people have heard of this. Now, the fight or flight response is actually two. There's actually 5 characteristics of it. Okay, fight, flight. There's freeze. Many of you may have heard of freeze. There's also submit, and then there's attach. Those last 2 are rare, but they are there, and they happen in more unusual circumstances. But the freeze part actually is visible. It actually happens in nature a lot. If anyone who's looked at spiders, what you'll see is when spiders are threatened, they literally freeze. And if they're in a net, if they're in their web, they might either fall within the web and kind of stay within the web somewhere, or they might fall out of the web. They literally freeze, and it's the exact same thing that happens to us when we feel, you know, when we faint and fall down. Their body literally freezes. So the vagal response emerged in us embryonically from hundreds of millions of years ago, back before we were spiders. Okay, it's that old in us. Okay, before we were spiders, and it's there to help protect us when there's danger. So you all have heard of the phrase, if a bear is going to attack you, play dead. Okay, now, not to say that will work. It doesn't always work, right? Playing dead, but it's based on this idea that if you play dead, a lot of animals don't want to attack something that's already dead. They want fresh meat. So if you play dead, if you appear to be dead to another organism, they'll leave you alone. So the vagal response is directly a learned response through evolution that most complex life forms have built into us. Because when we get stressed to the point where, like, for example, imagine you're in a troop and your group of human beings get attacked by a bear, and that bear is mauling and its blood is spewing. A lot of us will get very distressed from that, because either we are or our people around us are being attacked by this bear. And literally, many of us will faint. We will have strong responses, but we will faint. And that fainting is directly caused by the vagal response. Okay, it's not that we want to, but our conscious mind gets turned off instantly within a second based on this. And this is something that is in every person, and it can be forced at will. That's the power of this. Okay, so that's where I'm going to end. I think I might actually. I don't remember if I have another slide. I think I might have another slide. No, I don't have another slide. So that's where I'm going to end for tonight. But I want to discuss this and basically go a little more into this if people want to, and any other questions that we have.
Thank you, Sanjay. So now it's open up to everyone to either make any comments that they have on the presentation itself, or ask any questions that they have of Sanjay.
I've just got a very basic question, if no one else has got anything more intelligent to ask. How did they make themselves faint there? Did I miss that? Was that little trick they had? And also, just an observation I recently saw was a guy who's published a book. He was attacked by a bear and he survived it. It was a horrendous attack. It actually ripped his whole face off. at one stage. I don't know if you're aware of this book that he's just published, but he said he tried to play dead at one stage, and he said it wasn't a good idea because it just continued to eat him. He said it wasn't a very good experience feeling it munching on my leg, so he had to come back to life, and then that's when he survived. But anyway, that I digress. I was just wondering how they actually make themselves faint like that, please.
Yeah, it's I don't want to go too much into it because we're not supposed to do it. It's not something that
I thought maybe that's why you didn't disclose it. That's fine. Yeah,
it is. You can find it, but it's not. Basically, the answer, the intellectual answer, is that the vagal nerve actually can be affected by many aspects of our physiology. So you don't have to necessarily do it cognitively in terms of emotions. You can do it in terms of physiologically. So what they were taught to do was to do something to their body which triggers the vagal nerve, which triggers the response physiologically, and it causes them to faint.
Yeah.
But the same thing happens if you do it through your mind, through thinking or emotions.
Thank you.
You're welcome.
Next up, we have DLJ. DLJ, please.
Yeah, excellent. Thanks. Always excellent. Thanks very much. So I said I was writing something about it at the moment. You covered the main two aspects. One is which part of the system is on versus off, and then intensity of. I've got a few extra on my list. To do with sleep mainly. So, for example, deep sleep versus light sleep, REM, lucid dreaming, when you're in exercise, things like that. So I guess that you sort of covered that in the fainting part. I mean, it relates to. So what parts of the system are still working when you're under anesthetic, that kind of thing, right? So that's the one aspect. And then the other aspect was really the question we're really asking ourselves is what differentiates ourselves from other animals, right? And you covered that rather well as well. But there's an aspect, I was waiting for it and it didn't happen. So there's an aspect that differentiates ourselves from other animals, which wasn't on the list, or at least I didn't notice it. It was a bit fast, maybe. To do with the narrator, the narrative, right? The storyteller. So the ability to talk to ourselves, but also talk to others, right? So is that can only happen, presumably, yes, obviously when we're conscious, or do we count dreaming? The reason I'm thinking about this is because I'm sure you mentioned this on previous occasions, right? The split brain experiment, that's wrong. Split brain research, when people have had accidentally or whatever, they're two different parts of the brain, and then their left hand is, you know what I mean, right? So the left hand does, and then when they said, what did you do? They make a completely different story about what actually happened based on the stimulus, because it was left brain versus right brain picking up the thing, right? So that has got to be an aspect of consciousness or not, you tell me.
Yeah, there's actually many more other aspects of consciousness. What I'm going to cover, I'll have other talks later on, which will delve into more of these, and I'll demonstrate more unusual aspects in the animal kingdom, including humans, that we have around that. But split brain phenomenon in consciousness is very important, especially when we see other animals. It's actually very unusual in other animals. But it's a part of that, because when I talked about the 5 regions of the brain, the 5 large cephalons of the brain, remember those cephalons are in each hemisphere. We have 2 hemispheres, so technically there's 10. Okay, and so we can have a situation where in a person, a healthy person or a non-healthy person, one hemisphere is completely functioning, the other is not, or some of those cephali are functioning in both hemispheres and others are not, or vice versa. One hemisphere has one thing functioning, the other does not. So any number of combinations of things can be happening when we talk about split brain phenomenon, and so that gets more complicated. The point that you raised about the narrator, this is interesting, because I'm going to give you a perspective that is going to probably challenge that idea around consciousness. Okay, and it has to do with, I'm going to tie it into the cranial nerves that I talked about, the 13th cranial nerve, the most recent cranial nerve that we picked up on, that we recognize today. And I'm trying to think of how to explain it succinctly. It's a little complicated, but so when you refer to narration, what you're talking about is that in sophisticated consciousness, the brain is or needs to be aware of itself as a thinking thing.
Yeah.
And it needs to be aware that it can narrate, where it can communicate, where it can send information to either other parts of itself or to other organisms. So that's the aspect of narration.
Yep.
Now, that narration, most of us assume happens using the normal senses that we have, our hands, our voice, facial expressions, but that narration can happen in many, many more sophisticated ways, and it does happen in many more sophisticated ways. And I'm going to give one example which ties to the cranial nerve. Now, of the cranial nerves, I talked about all, the 13, and they all developed in life forms in our DNA. They basically embedded within our DNA. So our DNA has the history of how these cranial nerves developed and stayed in more and more complex beings. And the most recent one is called zeroth. Okay. So because we numbered them 1 through 12, because that's what we do, right? And we needed to add a new one. And because the order that we numbered them is that the most oldest one is 13, we couldn't make it 14 because the newest, the one that we've discovered is the newest one. It's not the oldest one. So it has to be less than 1. So we call it zeroth. Okay. So now the modern version of the cranial nerves goes from 0 to 13. Sorry, 0 to 12. It used to go from 1 to 12. Now, that zeroth cranial nerve is actually an extension of the first cranial nerve. And the first cranial nerve is the olfactory nerve, which has to do with smell. Okay. But the zeroth cranial nerve is an extension of it. It actually has to do with ability to detect, which means communicate. Okay, that's where the narration comes in. The ability to detect pheromones, okay, which are chemical messengers specific for sexual function and sexual communication, okay, between animals of the same species. So we've learned, and so there's a lot of research done since the 80s, and we've learned that this cranial nerve, and some call it an extension of the first cranial nerve, but a lot of scientists consider it a cranial nerve by itself, gives us the ability to communicate, meaning send out as well as detect pheromones, which are chemical signals from our skin and from our nose and our tongue, for that matter. It's all of it's connected. So, and there's a lot of research. Sapolsky, he's a very famous endocrinologist and neuroscientist. He with some others had done research which showed that, and it's not to be sexist, but the research is easier to do in women. That's why the research team did it in women. But they basically showed that women, depending on their ovulatory cycle, give off pheromones, and their behavior changes, even though consciously they're not aware of it. But sub-elements of their mind, of their brain, is aware of it because of the pheromone activity. And other people, especially males, also pick up on it. Meaning, so there's a communication between people of the same species of ovulatory cycle and reproductive cycle, etc., that happens at this level. So the narration that you asked about, DOJ, when you talk about it, this is an example where the narration can happen at any level of the brain, not just the levels that we think of higher level complex communication. It can happen at levels at the lowest level, because that type of communication happens not using the higher brain. The higher brain doesn't do that. It's the lower levels of the brain that causes our sweat glands to give off certain chemicals versus not. So anyway, that's an aspect of what you're talking about.
Marvelous.
Thank you, DLJ. Madeline, please.
Yes, this is a follow-on to the discussion of the olfactory nerve and pheromones. Is that is that part of the system that allows even a very basic organism to recognize itself? So that, for example, a starfish won't accidentally eat one of its own arms, or a sea urchin won't harm itself. In other words, the self-recognition part, does that originally stem from the olfactory system?
So I don't know. I'm going to take a guess, but I'm not 100% sure. But I think my guess is probably along the lines that so the olfactory system, it does detect our own pheromones, our own, and not just pheromones, many types of molecules that our body gives off, many particles that our body gives off. It detects a lot of that. Now, in one example where animals mark their territory, okay, that's an example where most of us recognize. That's an example where they do recognize it. They do recognize their own pheromones, but not for purposes of not eating themselves. It's for recognizing this is my territory, or my scent has weakened over months because they have to keep urinating, to build up the odor profile in the region. So if they sense that their odor is not there anymore in a region, they urinate again, or they release whatever chemicals they need to again. So it's not always for eating. But the organisms that you asked specifically about needing to recognize themselves so as not to eat themselves or a part of their appendage, I suspect that probably doesn't happen that often, or it probably doesn't happen in nature, because there would be other mechanisms that would need to exist, that do exist in the organism already. And the olfactory system is something that developed in most organisms. It's one of those things that developed much later in the evolutionary scale. The need to smell is not vital to survival. And it's not even vital to reproduction. So that's the reason why it's one of the later things that developed. So given that, that's why I suspect it probably is not used very much in, especially the lower organisms, for detecting themselves. Now, the thing that probably gets them to detect themselves, to avoid eating themselves, and I think the word detect is probably a confusing word, because it's actually not that they're detecting. It's probably that the physical nature of their body, the way that all of our bodies evolved, and the shapes of our bodies evolved, and the shapes of the movements that our bodies can conjure and can act in, work in ways that are based on our inability to eat ourselves or damage ourselves. So, for example, we can't reach behind or most animals can't reach behind themselves and grab their tail, or do certain, certain types of motions that we have, we cannot do to ourselves. And that's intentional evolutionarily, because those types of motions would not be beneficial to us. So only motions and body form and body shape and structure that are beneficial to survival survive through the gene pool. And so if you didn't have the sense of smell, and most smaller organ and early forms of organisms didn't have a sense of smell, or didn't have a sense of sophisticated smell, their smell sense was very rudimentary, and it probably didn't have the level of depth that would allow them to differentiate between themselves and another of their same species. Probably their sense of smell was limited only to food and danger and everything else, like a very, very limited sense of smell to, maybe tasty food and not so tasty food, but still limited to food and things like that, not to, the more sophisticated sense of smell that higher organisms have. So I don't know for sure, but that's what I would answer, because the part that I understand well is that the evolution of olfaction happened much later through millennia. Therefore, it probably didn't exist early enough for it to be important to prevent organisms from harming or damaging or devouring parts of their bodies.
Okay, thank you.
You're welcome.
Thank you, Madeline, for that question. Are there any other questions regarding tonight's presentation, or any other observations?
Yeah, I put my hand up.
Okay, go ahead.
Yeah, when you mentioned about playing dead, that made me think of something where I don't know how this would relate to consciousness, but maybe environmental awareness. If you're around like an animal and kind of that freeze frame, it's almost like you no longer exists there. In some cases, the animal may simply not be stimulated, be bored. And this is just based on my limited observation, but I've interacted like in nature. It's almost like if you freeze frame, just looking around, like for that millisecond, what happened to that thing there? There's no movement to indicate something's there, or simply like, okay, I'm not moving, nothing for that animal to consider. Like I could be reading too much into it, or just kind of bored on the nature trail. But sometimes I do notice that lack of movement. It's like, whether it's okay, I don't need to focus on that thing. It doesn't affect that animal one way or the other, but sometimes it is like once there's not that movement, It's like you're no longer there. I don't know if that's something that that kind of has to do, like you said, the awareness of the environment and realizing that person's still there, just the memory. Okay, no movement, nothing to really process for that animal.
So I'm going to give another example based on evolution and organisms to help explain that. So yeah, we are sensitive to movement, and this freeze response, or any type of freezing that organisms do throughout nature, is important because it actually helps them survive. Not simply because of the vagal response. The vagal response is not that often. You don't get into a situation that often for that to happen. But more often than not, when, let's say, a rabbit or deer is darting through the forest and there's a predator that's nearby, that predator will spot their movement and chase them. That's the reason why a lot of organisms have learned not to move, to basically stay still and to literally freeze their body for long periods of time, because they know that movement gives away their position. Now, the reason why this is important is because, and again, when we're talking about the brain and consciousness, when I was talking about information versus data, one of the things that I want to, again, bring up is that when we're looking, our visual system is highly sensitive to detecting motion. If you think about a frog, like a frog's visual system is unique in that it's able to spot a fly moving very, very rapidly, and it can coordinate the movement of its tongue relative to this fly that's moving very, very rapidly, and it can aim its tongue exactly where the fly is going to be in the future based on its predictive motions. That's how precise and that's how sensitive our visual system is at the level of a frog, right? And we are much further along than frogs, but we retain a lot of that ability. But the difference is that in our system, we still have that at a core, but we don't use that most of the time because it requires us to gain a lot of information. We've dumbed down our sensory systems, or I don't want to say dumbed down, but we take in much less information than we're capable of taking in because we don't need that information most of the time. This is why, like people talk about, if you're in an auto accident, the world goes on slow motion. That's a direct example of what happens, that when our brain realizes that survival is very critical during an accident, for example, because we're aware we're in an accident, we're aware that things are dangerous now, our brain literally starts to operate at a faster rate. It speeds itself up. That's what gives the perception of time slowing down, because our brain can actually do more things per second than ordinarily. So our brain does, it senses more things. So the world seems to slow down. So again, our visual system it's a yin and yang, that the rabbit that freezes because it knows that the bear's visual system is highly sensitive to motion. So because it's highly sensitive to motion, it has to stop moving completely for maybe seconds or minutes and wait for the bear to move away or turn its head away, and then the rabbit will dart away. So these are all tied together.
Just a quick follow-on to that. You had when you were talking about the information again, coming back to that delineation that we're making under the vagus nerve slide, where you had the parasympathetic nervous system. You had that that information. There's like very little information that's being processed on that slide. What did that mean exactly?
Let me put very little information, right? So let me pull that up. So basically the vagus nerve, again, what I said originally is that the vagus nerve is a long set of nerves. It's not a single nerve, it's a set of nerves, but it's not a set of nerves as in thousands and thousands of nerves. It's about a few hundred. I mean, I don't know exactly, but it's not a large number of nerves. And it's going to many different areas of the body. So what that means is that each nerve fiber can only carry a limited amount of information. And so the example I gave is that one fiber, or let's say two fibers from the vagus nerve, go into our esophagus, okay? And one of those will sense whether food is near our trachea. Trachea is the part where the lung entrance is, and the other nerve is near the part where it's away from the trachea. So using these two nerves, which are part of the vagus nerve, the vagus complex, okay, using these two nerves, you can sense that when food is going down your trachea, when your food is going down your esophagus, if it goes toward the trachea, the wrong direction, because you don't want food going into your lungs, that's dangerous. So if the food starts to go in that direction, the one nerve will activate and the other nerve will not activate. So that's 2 bits of information, right? It's very little information, okay? So the brainstem doesn't have to do any thinking. It's extremely simple. It's almost like a simple computer where if this and this, or this or this, it's like that type of processing. It's very simple processing. And given this information, that if this nerve is activated, meaning that the food is toward the trachea, and the other nerve is off, not activated, that means that the person is in a choking situation. That means that the output of the vagus nerve is going to, within the brainstem, there's going to be a processing loop there, which causes another signal be sent out of another nerve from the vagus nerve, which causes a gag reflex, or another one which causes a choking reflex. So the vagus nerves, okay, the complex of nerves, without any part of the brain, the rest of the brain, simply the brainstem alone, can cause you to have a gag reflex or a choking reflex based on where the food went. And you don't have to think about it. You don't have to even be awake during it. So that's what I mean by the amount of information that it's processing is literally bits of information. It's very, very little information. The amount of information that our higher order brains process are thousands and millions of times greater. So just relatively speaking, there's a huge difference between the amount of information. That's what I meant by that. And the fact that it's dealing, that it's split, that these small number of nerve fibers are split across the entire viscera of the body, means that each organ is getting a small number, maybe 10 at most, nerve endings that are going to that for detecting certain things and causing action or evoking certain things to happen. So it's a very small number of nerves that are actually sensing and controlling our body. But that's the reason why that the types of sensing and control is very simplistic. That's also the reason why oftentimes it makes mistakes. The reason why we faint in this situation is because that's a mistake. We shouldn't need to faint in that situation, but because there's so little information. Information is not high fidelity. It doesn't give us, gradations that our blood pressure dropped. Did it drop a little bit or a lot? It's not that type of information. It's simply it dropped enough. Therefore, it causes us to completely faint. So, again, hopefully that answered what you're saying. It is very little information.
Thank you very much. So let's go to Mike.
In response to commands seems to have an effect on consciousness as a property. In sleepwalking and sleeping and anesthesia, the patient, the subject can respond to commands in some fairly complicated ways and do complicated things, but is not aware of it and doesn't feel pain in doing things that might otherwise be painful. Does that have some impact in what you're talking about, or have you run into some of that in the discussions?
So, sorry, can you?
The person, Tyndall, in that paper you gave us said that anesthesia, you can still respond to commands. Other things that are the person, sleepwalkers can respond to commands. That seems to be, you're basically not aware, you don't feel pain when you're having surgery of some sort, but the patient can respond to commands even though they're pretty much open and feeling nothing.
Right. So, all of these different types of processes that cause the brain to lose the ability to process information. That's what we're talking about. So anesthesia does that, sleep does that. There are many types of brain states that can do that. And to understand that, the idea that we talked about tonight is that we have multiple regions of the brain and different parts of the brain can turn on or off at different times. So what anesthesia is doing is it's turning off certain parts of the brain, especially the higher parts of the brain. And it's leaving on the lower parts of the brain, the parts that deal with respiration and the brainstem, etc. So it's selectively turning off. And the word off is in a broad context. I hope everyone understands that it's not literally completely off. It's gradations that, the amount of activity, the types of activity changes under anesthesia. And under sleep, it's different. That even though in anesthesia and sleep, the same brain regions may be affected, the way that they're turned off in sleep versus the way they're turned off in anesthesia differs. And that's the reason why you can have, a lucid dreaming or lucid sleep that some people have versus in anesthesia that typically doesn't happen, because anesthesia is, another reason, because anesthesia, there's an anesthesiologist, a doctor, a physician who is monitoring your conscious level, your awareness in a sense, to make sure that you don't wake up. Because they don't want you to wake up because it can be dangerous during surgery. But in sleep, there's nothing monitoring that. So people can wake up. But, the short answer is that there are different parts of our brain. Different parts of our brain are turned off or on or both, depending on these situations you're talking about. And the way that they're turned off varies. So all of this put together gives us the multiple ways in which we lose consciousness, or lose consciousness partially.
I wonder to what extent that the patient may still be feeling pain, but is not aware of it and is not reacting to it.
Yeah.
Because
That's actually,
if the patient, if the doctor asks you to roll over, ask the patient to roll over, or roll on the side or the other side, the patient will respond. But in all other terms, and there are different levels of anesthesia, different levels of coma, and all those things. Okay, one more short question.
just one more thing on that, Mike.
Yeah.
So when we're talking about anesthesia, the subject of how anesthesia is administered and to what parts of the body, that's a whole another thing. The way you described it is that basically general anesthesia, but when the general anesthesia is given, the person may not necessarily be conscious. So the description you're giving is actually where anesthesia is applied to a specific part of their body, for example, to their abdomen, so that the surgery can happen in the abdomen, but the other part, their extremities, their limbs, their feet and hands and lips aren't anesthetized. So they can still speak while their abdomen feels no pain. So yeah, there's a whole lot behind it. It's much more complicated than
Okay. I think I was in your emergent session that you had, but I didn't capture what you used as a source for that. Was that Graziano or that was somebody else?
No, I don't remember what. I tend to forget the details as soon as I finished it, because if I go back, I'll remember. But I don't remember. There were some. There was, I think, Jakob was one.
Say again.
Jakob, but he was not a neuroscientist. He was I think a economist and a philosopher. And there was another neuroscientist I referred to. I don't remember exactly, but if you want, I can look it up. But I don't. What's the point of what is it that you want to get at? In terms of,
I think that Graziano thinks that and several people think that it's an emergent philosophy, an emergent thing that's part of how complexity theory works.
Yeah, most modern neuroscientists think that it's emergent. Yeah, I think that's, and not just neuroscientists, most physicists, most philosophers, most people who've looked into this think it is emergent.
But that it's still physicalism. It's not magic or quantum mechanics as Penrose thinks, but that there's a physical causal connection, but it's an emergent property.
Right. I mean, physicalism doesn't remove the possibility of emergent property.
Yeah. Okay, thank you. Very good.
Thank you.
Makes you think much of what you say. Thank you.
Thank you.
Well, Thank you, Sanjay. Another excellent presentation. So we have some meetups coming up, and I will just announce those really quickly. And one second. So this week, well, tomorrow, I know that we will be covering letters to Lucilius from Seneca, letters 31 through 40, and that is tomorrow at 8 p.m. That's an ongoing series, and we on Saturday we have the Asian philosophies meetup, the human world and Taoist politics, which actually really should be interesting. And then we have a workshop with Struppy on with our Bucky inspired comprehensivity series, and that is at 1 p.m. on Sunday. That is usually at 8 p.m. on Sunday now, but it's moved up since Struppy is in Germany. And then we have Poetic Mondays, and then we started all over again. So anyway, thank you everyone for a wonderful evening, and hope to see everybody soon.
Thank you. Thanks. Good night, everyone.
Thanks.